Hello, and welcome to Relaxing Facts. I'm Chad K, and today I will be talking about the sun. First of all, I want to give a shout out to our listeners in the following places: in Tel Aviv, Israel, in Austin, Texas, and Albany, New York, in the US, and in Mainz, Germany. Thank you for being faithful listeners to our humble podcast. You are very much appreciated. Each week, I share interesting stories and little-known facts on a variety of topics, accompanied by gentle, soothing music. My goal is to help you find a sense of calm during your busy day. Feel free to settle into a cozy spot and let yourself be carried away by these relaxing facts. The sun is so constant and familiar that daily life moves around it without a second thought. It rises, it sets, and people schedule their errands, their workdays, and their meals around the light that it provides. Yet this ordinary rhythm hides an extraordinary reality. The sun is a gigantic, blazing sphere of plasma that has shaped every feature of Earth, its climates, landscapes, biological patterns, and even its cultures. The sun's own story begins long before Earth existed. More than 4.6 billion years ago, it formed from a vast cloud of gas and dust drifting through the Milky Way. Over time, gravity slowly pulled the cloud inward, causing it to spin and collapse into a dense, hot core. As the pressure increased, hydrogen atoms began fusing into helium, releasing enormous amounts of energy. That moment, when nuclear fusion ignited, marked the birth of our star. It was not a gentle beginning. Fusion unleashed a power great enough to blow away the remaining cloud material, carving out a new solar system and setting the stage for planets, moons, asteroids, and eventually life. At the center of the sun today, fusion still rages with astonishing intensity. Roughly 600 million tons of hydrogen are fused into helium every second, and the energy released maintains the sun's structure against the crushing force of gravity. Understanding the scale of this process is nearly impossible. In a single second, the sun releases more energy than humans have generated in their entire history. Yet the journey of this energy from the sun's core to space is far from straightforward. A single photon created deep within the core will take thousands, or perhaps even up to 1 million, years to escape through the dense layers above it. When that photon finally reaches the surface and escapes, it travels the 93 million miles to Earth in just 8 minutes. The sunlight warming your skin today may have been created when ancient humans were learning to use tools, or when ice sheets covered much of the northern hemisphere. The sun's outer appearance gives little hint of the turbulent unfolding beneath. Although the surface temperature reaches about 10,000 degrees Fahrenheit, the core is far hotter, around 27 million degrees. Surprisingly, the sun's outer atmosphere, known as the corona, is even hotter than the surface, with temperatures soaring into the millions of degrees. This counterintuitive fact remains one of solar science's enduring mysteries. The prevailing idea is that magnetic fields, constantly twisted and broken by the sun's rotation and convection, may be responsible for heating the corona so intensely. But despite decades of research, the exact mechanism remains unknown, reminding us that the sun still holds secrets. While the sun may appear calm from Earth, it is anything but peaceful. Its surface constantly churns as hot plasma rises, cools, and sinks in enormous convection cells. Magnetic fields twist into loops that rise above the surface as brilliant arcs of plasma. Sunspots, which are cooler and darker regions, appear and disappear in an approximately 11-year cycle. This cycle influences solar flares and coronal mass ejections, massive bursts of energy and charged particles that can travel across the solar system. When these events interact with Earth's magnetic field, they can produce dazzling auroras, but they can also interfere with technology. Communication systems, satellites, and even the electrical grid can be affected. One particularly strong solar storm in 1989 knocked out power across Quebec for 9 hours. The possibility of a far larger storm remains a concern for scientists and engineers worldwide. Yet the sun is not only a source of potential disruption, it is also a protective shield. Its solar wind, which is a continuous stream of charged particles flowing outward, helps repel harmful cosmic rays from deep space. The sun creates a vast bubble around the solar system known as the heliosphere, which acts as a barrier against some of the most energetic radiation in the galaxy. Without it, Earth would be exposed to a dangerous barrage of cosmic particles that could threaten life. Everything on Earth traces back in some way to sunlight. Photosynthesis, which is the process by which plants convert sunlight into energy, drives the food chain. Every forest, every grain field, and every patch of grass is powered by the sun. Even fossil fuels represent ancient sunlight stored in plant and animal material billions of years ago. Earth's climates and weather patterns also depend on how sunlight heats the planet unevenly. The tilt of Earth's axis determines the seasons, while variations in the sunlight drive winds, ocean currents, storms, and droughts. Even small changes in the sun's output can influence long-term climate patterns, shaping entire ecosystems. Human understanding of the sun has evolved dramatically across cultures and centuries. Ancient civilizations recognized its importance long before they understood its nature. In Egypt, the sun was personified as the god Ra, ruler of the sky. In ancient Greece, it was Helios, a god who rode a blazing chariot across the heavens. The Aztecs conducted ceremonies to ensure the sun would continue rising. Stonehenge in England appears aligned with sunrise on the summer solstice, suggesting that ancient peoples tracked solar cycles with remarkable precision. To many early societies, the sun was not a distant star, but a divine presence that governed life. Modern science reveals a more detailed, but no less awe-inspiring picture. One of the most intriguing discoveries involves solar neutrinos, which are tiny, nearly massless particles created in the sun's core. Early detectors found fewer neutrinos than expected, raising doubts about whether scientists fully understood how fusion worked. Eventually, researchers discovered that neutrinos change from one type or flavor into another as they travel through space. This solved the mystery and provided crucial insight into both particle physics and stellar processes. In studying the sun, scientists learned something fundamental about the universe itself. Space missions over the past decades have brought us closer to the sun than ever before. NASA's Parker Solar Probe is currently traveling through the sun's outer atmosphere, gathering data from regions once thought impossible to reach. By sampling particles in the corona and measuring magnetic fields up close, it is helping scientists understand phenomena that were previously only observed from afar. Another mission, the Solar Dynamics Observatory, watches the sun continuously in multiple wavelengths of light, revealing intricate details of solar flares, loops, and storms that the human eye could never detect. These tools allow us to observe the sun not as a smooth yellow disk, but as a dynamic, ever-changing world of intense activity. Considering the sun's future invites reflection. Like all stars, it is governed by the laws of physics and the supply of fuel in its core. Today, the sun is midway through its stable life cycle, known as the main sequence. It has plenty of hydrogen left to fuse and will continue shining steadily for about 5 billion more years. Over time, it will grow brighter, gradually increasing the amount of energy reaching Earth. Eventually, the sun will begin expanding into a red giant, swelling so dramatically that it may engulf Mercury and Venus, and potentially Earth itself. After this dramatic phase, it will shed its outer layers and collapse into a white dwarf, a dense, faint remnant that will slowly cool over billions more years. This distant future is not cause for alarm. It lies far beyond the time span of human civilization. But it reminds us that stars have life cycles, just as living organisms do. The sun's eventual transformation will bring an end to the environment that makes Earth habitable. But it will also contribute new material to the galaxy, continuing the cycle of star birth and creation that began long before our solar system formed. Even though the sun's ultimate fate is unimaginably far away, its presence today is the anchor of life. The energy radiating from it makes Earth warm enough for liquid water. It shapes ecosystems, fuels biological processes, and drives every breath of wind. The sun is the quiet architect of landscapes and seasons, the hidden engine that powers nearly every living thing. It dominates our sky and our biological rhythms while remaining so distant that its light must race across space as 186,000 miles per second just to reach us in time for breakfast. That brings us to the end of this week's talk. If you enjoyed this episode of Relaxing Facts, then please consider leaving a comment or clicking like or even subscribing. I hope you have a fantastic day, whether you're taking a moment to unwind or simply enjoying some calming listening. Thanks so much for being here. I'm Chad K, and I look forward to seeing you next time. Bye.